It's Monday, August the 8th, 2016, and we're here at the Computer History Museum. I'm David Laws. I'm semiconductor curator here at the museum, and we're going to interview John East on his long and important career in the semiconductor industry here in Silicon Valley. John, I'd like to start out by talking a little bit about where you came from and how you became interested in technology. Where were you born, and where did you spend your early childhood?
I was born in Texas because my dad was in the Air Force during World War II. Lived there my first year. Then we moved around a little bit until I turned 5, at which time we moved to San Joaquin Valley. So I was pretty much raised in Merced in San Joaquin Valley. And it was not the kind of student that you wanted to have if you were a teacher, because I was mischievous, I guess. So in order to settle me down, my 6th grade teacher tried to get me interested in electronics. And that meant tinkering around with crystal sets and things like that, and it seemed like a fun thing. So I decided then I wanted to be an engineer, and I was. I wasn't a good engineer, but I was an engineer.
Right. Do you remember the name of the teacher? He must
Sure,
have made a big
Mr.
impression.
Fonts. Mr. Fonts, F-A-N-T-Z.
Good.
He was quite an old gentleman then, so I'm sure he's passed away. If I hope he's not, and he sees this and he recognizes I'm giving him credit.
Good.
Or blame, however you would judge that.
Yeah, we all have somebody like that in our lives.
Yeah.
I had a teacher who was great benefit to me. And so you stayed in Merced, went to high school there.
That's right.
Throughout your youth, and graduated when?
I graduated from high school in '62 and started Berkeley in the fall of '62.
Okay. And at Berkeley you started?
Fall of '62 as a EE, electrical engineer. I did have one semester where I actually changed majors into physics because that was more fun for me. But I'm a practical guy, as you are, and it was a lot more practical to have an engineering degree than a physics degree, so I went back into EE and got out of there in '68 with an MSEE and an MBA.
Good combination for moving into Silicon Valley.
It seemed like it, yeah, it seemed like it.
And were there any teachers or any people you met at Berkeley that left an impression on you that you think was valuable later in your career? Never came across Andy Grove's physics class or anything like that?
I actually took his physics class when I was at Fairchild because it was given up at the R&D place, but I was unaware of Andy Grove when I was at Berkeley. I guess the most influential guy would have been Donald Peterson, who passed away a few years ago, but he was the guy that drove SPICE and was an early semiconductor guy. And a Jekyll and Hyde professor. He was the nicest guy in the world and a really smart guy and friendly, and he would pat you on the back, but he would also stand in front of what he was writing on the chalkboard and talk really fast. So I never walked out of one of his lectures having understood anything about what he said. But it was clear he was a good guy and knew what he was talking about.
Now he was also an author, right? Didn't he write a book?
Yes, he wrote the book they referred to as The Yellow Peril.
Okay.
And the reason they called it The Yellow Peril is when he was writing it, he would type up drafts of whatever the chapter was and give to us. And I had the bad luck of being in his class the year they wrote it. So he'd give them to us when we'd walk in there. And of course I just described that I couldn't understand his lectures, but I thought no problem, I've got the notes that he's passing out. But you can never get notes right the first time. There are always mistakes, right? And so I'd go home with the notes and try to work my way through them. And I must be stupid. I don't understand this. I don't understand this. And I wasn't the kind of guy who go ask the prof. I was afraid of the profs. So I'd feel like I must be the dumbest guy in the world. And then I'd go to the next lecture, and he'd start out by saying, well, I hope you caught that in the notes I had a mistake here and here and here. And then when they actually put it together into a book, which they did right at the end of that semester, there was a yellow cover paperback. And it got referred to by myself, among others, as Yellow Peril. It was yellow, and you read that book with Peril.
Great story.
So that's Yellow Peril.
Did you study much in semiconductor technology while you were there?
No.
At Berkeley? Very little?
No. You picked your specialty, and I picked communications, which I regretted for the next 10 years is thinking, gee, I should have done computers or semiconductors. But in fact, communications made a return in spades about 30 years after that. But by then, anything I had learned, I'd forgotten. So, but no, I was not a semiconductor guy. In fact, I didn't much like them. until I started working with you, Dave.
So how did you end up at Fairchild?
Um, I was going to graduate in December.
December of?
December of '68. Not graduate, but I was going to get my master's degree in December '68. And Berkeley was set up with two, or I guess they would be biannual college recruiting programs where all the people would come in and the students would go and interview and get the jobs and what have you. So one of them was in the summer, one of them was in December. So my plan was to go through the college recruiting in the December one. Then I didn't meet my wife-to-be, but I'd known her for a long time. But I was going to say we decided, but pretty much she decided that it would be better to get married in June. And if we were married, I had to be out of school pretty quick and earning a job. So I, instead of taking the summer off, I went to school in the summer, got out in September. But there was no college recruiting program in September. So I wrote 40 or 50 letters, and there was a college placement handbook that had the address of these companies, and wrote the letters, and dear sir, you don't know me, but I want a job. And got back, I think, 3 responses, which was a little despondent. One was from IBM, where I interviewed, and they didn't offer me a job. One was from HP, where I interviewed, and they didn't offer me a job. And one was from Fairchild, and all I knew about them was they made cameras, because that was Fairchild camera. I said, I guess I'm going to be a camera guy. Interviewed with them, and they were all excited. They thought I was the greatest guy in the world, and they offered me a job on the spot. This was in maybe May of '68. And they knew that I wasn't going to be done until September, and they said, that's not a problem. We'll wait for you. You're going to be wonderful. In fact, you don't even need to communicate with us. Just the day before you're done, ready to come, call me, and we'll make arrangements for you to come, and everything will be great. And this was at a lunch that I had with a guy named Gene Flath, who you would know, Dave.
Intel fame.
Yeah, that's right. And a guy named Jerry Briggs, who was the HR guy, and they both gave me their business cards. So when I had one day to go, I'd just taken my last final and was ready to go. I picked up the phone and called, and a lady answered the phone. I asked, can I please speak to Jerry Briggs, because I was afraid of Gene Flath. He was going to be my big boss, right? And Briggs was the PR guy, or not PR, HR guy. And this lady said, there's no Jerry Briggs that works here, and I've never even known a Jerry Briggs. And we debated for a while, and after a while I asked her, well, how long have you been there? And it had been a couple of months, I can't remember the exact amount of time. And the department had turned totally over in that period of time. So I thought, that's not a problem, because I've got Gene Flath's card as well. I'll call Gene Flath. So I called Gene Flath's number and got a secretary. And she said, there's no Gene Flath here, and there's never been a Gene Flath here in all the time since I got here. Well, how long have you been here? A couple of months, something like that. So fortunately I had the offer letter, and I told them I had an offer letter, and they said, well, okay, we'll honor it. You drive down here and ask for somebody. I don't remember who it was. But what had happened, of course, Dave, you would know all too well, was that Noyce and Moore left in order.
A month after I joined, I don't think there's any connection.
Okay, so they left, and then Sherman Fairchild brought in Les Hogan.
Right.
Hogan brought in his 7 top lieutenants, and they were referred to as Hogan's heroes. They proceeded to fire about a third of the upper ranks. About another third of the upper ranks said, well, wait a minute, if I stay around, they're going to fire me too. So everything had turned over. So when I got there, nobody knew what was going on. Nobody knew who their boss was. What a zoo it was. But that made it almost seem like fun. And the other thing that was noticeable was in the other companies where I interviewed, the managers were 40-year-old, 50-year-old people, which today doesn't seem very old, right? But then it seemed like ancient. I said, you mean I've got to be around 20 years before I can get a manager job? That's terrible. In Fairchild, the managers were kids. They were 25 and 26. And not only were they kids viewed as being experts in their field, because the field was that young. Did I get a little carried away at the answer to that question?
No, I think that I've heard the story before, John, and it's consistent and you tell it well. Thank you. Do you remember, who did you work for then when you started? You must have had somebody as a boss, and what was your role?
Well, actually, when I got there, they didn't know I was coming, or rather they had 24 hours notice. And so they looked for the first possible job, and the first possible job was not as an engineer, it was as a foreman in wafer sort and class, which people today would refer to as probe and final test, but we call it wafer sort and class.
Yeah.
So they said, let's just stick you in here for a while and you can supervise this group. And,
with zero experience.
With zero experience. And engineering job will open up shortly. And so, yeah, I went in there, and there were a whole bunch of ladies, because then it was very sexist. They were all ladies in there, and they were doing things that I had never seen and never heard of. And my immediate boss was a guy named Les Ferber.
Les Ferber, yeah.
Do you remember Les?
Yep.
And a very nice guy. I didn't get the feeling he much knew what they were doing either, to be honest with you. But he took me, got me a smock, and introduced me to the secretary, and then took me into the wafer sort and class area. Yeah. And then he said, "I've got a meeting. I've got to go." So he left, and
all of a sudden,
I'm looking around. And so I started introducing myself to the ladies, but they didn't think that was strange at all, because in those days people came and went, at extremely rapid. So they properly diagnosed, but they didn't need to bother being that nice to me, because I'd be out of there shortly. And they were very nice ladies. I hope some of them watch this, because I appreciated them. They taught me what little I knew back in the time. And then 3 months later, I was a product engineer.
Okay.
Was that a choice, or was the job they offered you?
That was a choice, because actually, gee, Dave, again, you remember this history, but they were dividing digital integrated circuits, which was under John Kerry, who's a fascinating subject in and of himself, into 3 different groups. And actually, there weren't enough good engineers, so there was a little bidding war. Each of the 3 different groups wanted me to join them. So it was kind of fun. I got to pick, and I made a pick that in retrospect was probably the worst pick, but it all worked out all right.
And what did you end up, which group did you end up in?
I ended up working for a guy named Doug Finch, who had been brought in from Motorola by the Motorola guys, and his group was called Special Integrated Circuits,
yes,
SIC.
The custom circuits, the CML and the UNIVAC circuits.
Yeah, that's right. Yeah. That's right. And in fact, you and I met each other because one of my products was the CML that we never finished developing, and one was the temperature compensated ECL.
Yes, that's right.
But those ended up going nowhere. One of my products was RTL, which was the very first integrated circuit line ever in the world. And it was a kind of a brain dead circuit. It had any number of problems, but that kind of made it fun for an engineer. And it's really fun to look back and think, I had something to do with that very first line that ever came out.
Micrologic.
Yeah, Micrologic. That's what it was, Micrologic.
Interesting. That's a good place to come into the semiconductor industry, because you had a chance to see every facet of processing, testing, design.
Yep.
So it must have stood you well in your future career.
It stood me really well. There was I had so many different bosses. And in fact, my boss didn't dictate that I do this, but I'd heard of other bosses that dictated it, so I decided I'm going to do it, and that is womb to tomb. Do your own design, which in those days was almost trivial for a DTL, let's say, and your own layout, which again was almost trivial. We didn't make our own masks because there was a mask shop, but you'd do the drawing, which was easy, cut the rubeliths, the rubies as we call them, take them to the mask shop, then they'd give you the masks. Take the masks in the fab and make your own line. And there were a couple of things they wouldn't let you do in the fab. Evaporation systems are tricky, so they would insist on doing that. But as far as the masking and the diffusion, things like that. So yeah, I went womb to tomb. Did a design, had the mask made, went to the fab, made the whole thing, wrote my own test tape, and made you feel really manly at the time. Yeah. But Dave, there's not one of those things today that I could do. Each aspect has advanced so much that I wouldn't understand the first 10% of any one of those aspects.
I would understand the 10% of a circuit today.
Yeah, that's right. That's right. Well, in fact, 10% of a circuit today is 1 billion transistors, right?
That's true.
That's a lot of transistors.
That's for sure. Interesting beginning, John. So how long did you serve as a product engineer, and what was your next step?
Well, it was a madhouse at Fairchild, which made it fun. But the fact that it was a madhouse led to giving you the ability to change what you were doing almost at any time you chose to. So I did that a lot. So I did some circuit design, I did some process engineering work under the guise of a product engineer. I was a product engineer for a long time. I was a wafer sort and class foreman. I was a general foreman in those areas. just because jobs were opening up all the time, and it always seemed like the best way to get to the top would be to have breadth. That, in fact, even then you could see that somebody who was an expert of this, who moved to a supervisor of that, who moved to a manager of that, then kind of had trouble because you needed broad-based knowledge, and they tended to not have it. So I did every possible different job, including a year in marketing there. And I know you'd find that hard to believe, Dave, but I did do 1 year of marketing.
That's good.
In total was there 8 years, 8.5 years.
Okay. And what was the last job at Fairchild?
The last job was working for Lowell Turf.
Yes.
Fine man, I miss Lowell, as his marketing manager for MacroLogic, which was a 2901 competitor.
Right.
And then what happened, though, that really made the big difference was the management, mentioning names here, but the top level managers when I was there, who always took care of me, were Dave Jurorf and Paul Regan.
Yes.
And also for a while a guy named John Sessenberger. And there was not a revolt, but basically we were losing money and had been losing money for quite a while. So in those days it's easy to fix. You just throw all the bad guys out and get new guys in. So the new guys that came in were fine guys and what have you, but we didn't really know each other, and there was no bond. They didn't remember that I'd been working my butt off for them. So it was a kind of a start from scratch, and of course they had the people that they liked who then were seemingly getting the good jobs. So I got an offer from Raytheon to be an operations manager there, and that was a good-looking job because I had wafer fab, process engineering, product engineering, circuit design, marketing, the whole shooting match of a very small group, but it had the whole shooting match, and again under the theory of breadth is good. I thought that would be good. Now that ended up being not a very good company to work for, but again, it was a learning experience.
And this would be about, you said 8 years, 76 or so?
Yes, I took that job in December of '76 and left it in April of '79 when I caught on at AMD.
They're 3 years then.
Well, it's 2 years and 3 months.
Yeah.
So let me ask a question about Raytheon. My impression of Raytheon has always been that they were strongly tied to the military and to the government type thing as their primary target audiences.
Yep.
So you gaining some knowledge of that was probably going to be something you're going to use later.
Yeah, that's perfectly logical, but not the case.
Okay.
Not the case. They certainly were tied into military. That's why Raytheon parent company kept them around to do the little things that they couldn't get other people to do for them. Yeah, I just sort of backed into military later for a variety of reasons that didn't really have anything to do with claiming that I knew something about it.
Sure.
It was just perversity.
So in '79, you moved to AMD.
Right. One of the
What was the process of recruiting, and which group did you come into?
I had met a couple of times with Gene Connors, who's one of my favorite people in the world. One I was at Raytheon, and we were going to, in fact, we did form a second source agreement. I think that AMD felt, and in those days I think it was true, that you really needed second sources. And of course you never want a strong second source. So I think Gene got out the phone book and looked under the category of weakest possible second source and called me up because he had been at Fairchild when I started there. I knew him just a little bit from there. Called me up and we actually put a deal together where we became a second source of 2901. Then AMD was doing really, really well back in those days, and they decided to split the group up. I can't remember what they called it, but they split it into 3 pieces. And one was interface, one was logic, and one was microprocessor. And they wanted what they called a product manager for each one of those pieces. And they had 2 guys that they liked, Bob McConnell and Don McIntosh, and they were looking for a third. So he interviewed me, and we always liked each other, and he offered me a job. And I took.
So you came. That was the interface group that you
came into the interface group. Right job, right time. RS-232 was taking off. I had, to be honest with you, no idea what that was, so I get the books out. What's RS-232?
Believe it or not, it's still taking off.
I read an article, just the other day that it's still
around.
well. But that's where we made our fame in interface. The group did
Yep.
really well, it grew like crazy, and it was
Yep.
because of RS-232.
And that was AMD's most profitable group for many, many years.
Yes, yes. Which, again, it was dumb luck, because actually Gene asked me which group I wanted, and I'd done some microprocessors, I'd done a lot of logic, so I thought, I'll
Right,
take the
right.
interface. And then we ended up making money hand over fist, and that made me look good.
Sure.
So allowed me to do probably better than I would have
And
otherwise.
that's at the time when we were peers.
Yes.
You reported to Gene,
Yes.
and I reported to Gene
That's right.
as, I don't know, marketing
Strategic
manager,
marketing
strategic
manager.
marketing manager,
Yep,
right,
yep.
for that group.
That's right.
Interesting times.
They were.
What was your next move, Jim?
Well, I stayed at AMD 10 years, so should I elaborate on that?
Let's hear about the products and the people that you think were important at those times.
Okay. So who was important? Jerry Sanders is important, and Tony Holbrook was important. Those were just really good guys from totally different standpoints, as you know better than I do. But to this day, I love both those guys. Jerry, I fell off of Jerry's dance card when I left the company, but I think I'm mostly back on it now. But he never took kindly to people saying, "Hey, I quit."
Right, I did that too.
Yeah, you did. But off the top of my head, those would have been the two role models. But what happened? They decided they were going to add an extra level of management, because this was back when we were still growing like crazy. So they concocted a new level of vice president, and I was lucky enough to get one of those jobs. And in fact, analog was mixed with interface, and that was one of the groups. And logic and microprocessor became the other group. And again, Gene asked me, "Gee, if we make you VP of one of these two groups, which would you like?" And I've been doing interface for 2 years. That's the only time I've been there. So I switched back over and do the other. So I became VP of I think we just called it logic, but it had the logic and the microprocessor stuff.
So you're doing the 2901 again back at
Yes,
AMD at
exactly.
this
Doing
point? Okay.
2901 again. And again, I was very lucky, because 2901 was doing fantastically well, because of the good auspices of DEC and Data General and people that are well represented around this place. They took good care of us. And you have a lot of 2901s in this building. We could get a screwdriver and take this stuff apart and find a lot of
It
them.
was interesting that in a previous interview with John Berkner, Jeff Katz and I were the co-interviewers, and
Okay.
Jeff had a lot of background working with 2901.
Right.
I had a lot, because I built stuff at Lawrence Labs. And John had also mentioned that was part of his background as well. We just thought it was something that sort of came and went, but apparently it really had a bigger impact.
I think there were 14 second sources
Were there really?
on the 2901. Everything from CMOS and gallium arsenide.
Yeah.
It was in many gate arrays, became a cell later
Yes, yes.
in cell designs, and of course, and it was always much larger than life at AMD than it really was in terms of revenue, in terms of the importance and all the other business that it brought in. We sold probably 10 times as much memory associated with the 2901 as the chip did itself. So that was, again, a good product to be involved with, John.
Yeah, luck has a lot to be said for it, Dave. And,
Make good luck sometimes.
and I was lucky. I was very lucky. The 2901, you and I traded emails a little bit, and the thing that I always think about when I think about the 2901 was that was the last vehicle around that allowed a computer company to design a computer. Is they'd take our little 4-bit slice, and they'd be happy that we had the how to add 2 + 2 algorithms. They didn't worry about that.
Come up with your own micro word.
Yes.
And use
Yes.
it as you choose.
Yes,
Yeah.
and I think the computer people liked it because of that as well. I think computer people like to say, "I'm a computer guy, I design computers."
yeah.
Of course, you know they do not do that now. Intel designs computers, ARM designs computers. That's pretty much it. Computer companies put nice boxes around them, and I don't want to minimize what they do. They do a lot of things, but among them is not designing.
Creating computer architecture.
So anyway, next step was they reorganized again at AMD and decided they were going to reorganize the company into 3 major segments, and one segment was memory, one was programmable logic. By then it was clear that programmable logic was going to really be a big factor, and AMD had just bought MMI, so that was going to be a big group. And the last was what they called general logic, to differentiate it from programmable logic. So that had General Logic, which is what I ended up with, had all logic products in the company, including MOS ones. So that's the first time I actually had anything to do with MOS. And that probably happened in 1985. Until then, I'd always been involved in bipolar. And my expertise, what little expertise I have, is in bipolar. And of course, nobody would give you a nickel for a bipolar transistor anymore. So it's like a buggy whip, you know. You read about the importance it had, but don't buy them anymore.
Right. You must have learned about a lot about what makes a good manager in this process. You saw so many groups, so many projects. Some succeeded, some didn't. What do you see as some of the clues to how to pick a good manager in that business in those days, John?
Well, I always wanted to be a CEO, even back in college. It seemed like, you know, I had the work ethic that my mom and dad had given me. You're going to work hard. And then it seemed like, well, as long as you're working hard, you may as well be a CEO, right? If I were just going to hang out, kind of fool around, then. So I always thought a lot, and in fact even made notes of the managers that I had and what they did that was good and what they did that wasn't good. And then of course you have to match it up with who you are. When I first got to Fairchild, I think I coined the term John Wayne management, but I still use that term today. And John Wayne management was you punch them in the nose, you kick them in the ass, you shoot them, you holler at them, cuss at them. And you remember the guys at AMD, I won't mention names because they're still alive, they may see this, but there were a lot of John Wayne managers there. And it seemed like a good style, and I thought, okay, that's the successful style, I guess I better learn that style. But it rapidly became a bad style when you realized that there were many other places to work in 1975. As opposed to what there was when I got there in 68. In 68, you kind of wanted to work at Fairchild. That's what was there. And so they could kick your ass and you would stay and take it. But later, your boss is abusing you. You get into your back pocket, you pull out the 5 offer letters that you have there. I'll take this one, tell your boss you can kiss your rear end, and you're out of there. So it seemed to me the John Wayne management style took a dive. Only to recur when a company was super successful and you had options in the company and you didn't want to leave the company because the options were doing very well. Then John Wayne could be employed again. But kind of in the more average job, you had to do more of a participative. You had to listen. You had to pay attention to what people were telling you. You had to be a leader. You had to be somebody that people would listen to and want to work for. And that's, I think, a lot harder than being a John Wayne manager, although I don't have much John Wayne in me, as you can see by looking at me, so I would have been a particularly poor one of those.
You look like a little Clint Eastwood to me.
Physically I get that all the time, but I don't have any big gun, and I don't say, go ahead and make my day. That doesn't happen.
Sure. How about innovation? How would you stimulate innovation in a company as large as AMD?
You know, I went to a SIE dinner once, and I don't know how this happened, but I sat at a table with Gordon Moore, and I actually sat right next to him. And I can't think of why that would have happened now, but I was thinking about it the other day. But anyway, I got to know Gordon, the nicest man in the world. I'm sure you interviewed him 20 times. So just a really, really, really nice guy, and I asked him that question. And he said, well, first of all, you hire super smart people that want to invent. And second of all, then you encourage them to invent. But third and most important, you let them know what it is that you wish were invented. Because otherwise, they'll be off doing all kinds of crazy things that you won't have any need for. And I said, those are the 3 things we've done, and we just haven't had any problems, man. We get more inventions at Intel than we know what to do with. We reject them hand over foot because there's more than we could possibly deal with. And so I think that's good advice. You make sure that the inventors get the credit. You don't try to steal it from them. You make sure they get praise and glory, and hire smart people, and they'll go out and they'll do the invention.
You mentioned earlier the difference between a Tony Holbrook and a Jerry Sanders. 2 totally different personalities in style and appearance. Why do you think that kind of combination works?
Well, that was a classic, I was going to say classic, but that's not going to fit very well, but I was going to say inside, outside. You have to have a guy with a vision and a lot of charisma to make people want to work there. And boy, Jerry was that. And it felt like it got harder to have a good vision towards the end, but the decade that I spent there, Jerry's vision was perfect. And I think, Dave, that you actually squelched the vision towards the end along with Clive Guest, because you two guys together, well, okay, let me back up a little bit. The super simplified Actel vision in the early days was building blocks of ever increasing complexity. And that sounds pretty simple, but it pretty much encapsulated what we were trying to get done. Then there was a second vision, equally important, but it came from a little bit different angle, which was people first, products and profits would follow. Right. So those are sort of the guidelines, and those are really good guidelines, and were well articulated, and they made you want to work there, and they made you understand what it was you were trying to do there, and how it was you were trying to act there. So I thought they were really good. But you and Clive ended up concluding, and I think this particular email, not an email, it was actually a memo, came from Clive, but I think you were in on it. But it said, you know what? People don't want building blocks anymore. People want microprocessors, people want memories, and people want gate arrays. And that's it. So this building block gig is going to come to an end. And you were certainly right, and it did. But then, where do we go from here? That got to be pretty hard. Because Lord knows nobody wanted to be in memories. As we talked about when I walked in, you had just done a study finding 300 different people that made CMOS gate arrays. Should we be number 301? Probably a bad idea. We, of course, had a position in microprocessors, but it was as a subservient to Intel, and that relationship was no fun at all, and I'm sure you have lots of interviews that dealt with that one, so I won't try to get into it more. So it made it really hard to figure out where to go from there.
Yeah.
And of course, they did eventually settle out on NVN memory and Intel microprocessors, but it was a whole lot less fun.
And there was a stab at communications for a while, too.
Yes.
With the Siemens and the Ericsson and the NEC relationships.
That was under me when I was there, and you're right, in retrospect, had I done a better job of really getting a good position there for us, we would have probably done better. I remember my big pitch was FDDI. I really believed in FDDI and a product called Taxi, and we were spending quite a bit on ISDN. So we spent like drunks on communications. Yeah. And now if you went back and looked, well, how did FDDI and ISDN do? And the answer is the money that I spent pretty much was flushed down the toilet. So didn't work out the way we had in mind.
There were so many horses to back.
Yeah, there were.
There was much luck as judgment, I think, which one came out of the starting gate. Yeah. Or survived coming out of the starting gate.
The big mistake probably that AMD made there was, yes, I was running that group, but I was a product engineer of bipolar transistors. I didn't understand FDDI, and I didn't understand fiber, and I didn't understand this and that and the other, and I'm trying to make all these decisions. Later, the successful companies in semiconductors didn't have people that understood semiconductors whatsoever. Yep. In fact, it's almost scary when you talk to them. They don't know the first thing about semiconductors, but they understand the market that they're trying to make a semiconductor to fit into. Right. And they were far more successful than a bipolar engineer who understood how to raise beta in an adverse environment.
It's a system architect thing where somebody at this more abstract level can identify what the functions need to be. I have no idea how to make them, but this is what we need.
Yes, that's exactly right. And those were the successful people, which it felt a crime to me at first, but in retrospect, it's the way it had to go, and it was the right way to go. But at first I thought, those guys don't understand the first thing about a semiconductor, and they think they're going to run a company. And then, of course, they demolished me, causing me to think, well, wait a minute now.
So after how long you at AMD, John?
10 years.
10 years. And so you're at the top of this company that was struggling a bit by then. Mm-hmm. What was the decision process in taking the next step? Did you think it through, or did something appear on the doorstep?
I thought it through ad nauseum. And I'll now repeat a story that you and I talked about 10 minutes before we started this interview. There were many startups in the Valley in the early to mid 80s. And AMD was very successful, and I was a relatively well-known executive at AMD, so I used to get offers all the time to run and be the CEO of a company, which I badly wanted to be, but I wanted it to be a successful company, not a failing company. And even in those days, you could see most of the companies failed. Not the only type of company, but by far the dominant type of company to offer me the CEO-ship was one of the 300 CMOS gate array companies that I knew about because of your study. And usually I would go and talk to those guys because knowledge is power, but I never wanted to take one of those jobs because there would be too much competition, and too much competition generally leads to failure. You can only have one or two successes, so I always turned those down. But another comment you had made, Dave, was if somebody could just figure out to make a gate array that was programmable. You didn't call it an FPGA because we actually coined that term at Actel later. But if you could make one of these gate arrays programmable, now that's what everybody would want. And I got a call in '86 from a guy named Amr Mohsen. You should do an interview somehow on that subject, but not with me. And Amr Mohsen had started a company called Actel. And the concept of it was to make a field programmable gate array. Actually, that's not quite true. When he founded it, they were going to make a CMOS PROM, but later decided, gee, we understand how to make a programmable gate array, and we could do it, so let's drop the PROM and do a gate array. So in '86, they offered me the job as the president of Actel, reporting to the CEO, Amr Mohsen. Now, that gave me some pause, because Amr, whereas he was an extremely bright guy, he was the guy that single-handedly, all alone, proofread Carver Mead's text, Mead Conway. The whole shooting match, Carver gave to Amr, who was his student, said, here, proof this for me. So Amr did the device physics, he did the architecture, he did the English, he did the whatever. So extremely bright guy. But there were personality idiosyncrasies that caused me to think maybe I'd not be well off if I took the job. And then when I talked to Tony and Jerry about it, they made me an offer I couldn't refuse to stay, so I turned the job down, and then turned down a few more CEO jobs with other CMOS gate array companies. But finally, Actel came back in '88. And by the time '88 had arrived, Law's premise about we only want microprocessors and gate arrays and memories was really coming to fruition. I could see it affecting what I was doing really strongly, and I didn't know what to do about it, nor do I today know what to do about it. Actually, it was a tough problem for them. And the second offer at Actel was as CEO with Amr working for me. And it just seemed like a better deal. So yeah, I thought about it for basically 2 years. And I really liked the concept of the antifuse, because I still viewed myself as being a technical guy, and it seemed to me like the SRAM FPGAs that were already there would have a lot of problem because they would always be losing bits. It would be very, very difficult to have a reliable product, because it was clear you were going to get to the point where you had 1 million bits configuring this thing, and if one flips, it would be it could corrupt the circuit, but you wouldn't be able to tell the circuit was corrupted or not. It's a nightmare. The antifuse is clearly a better way to do it, and so
from a bipolar technician's point of view.
Yes, that's right. So actually, when I took the job, it was sort of by your advice, even though I didn't call you, Dave. But it's a programmable kind of a gate array, which is going to be a wonderful market. That was clear, and they are about 5 years behind Xilinx and Altera, but they have a better technology. And my sister was a Harvard MBA, so she used to tell me about the case studies that they did there. And I can't remember if she told me about this case study or even if there wasn't such a thing, but I tell the story as though there was. Okay, a company is out there and it has a product and a nice market. But another company comes along 5 years later with a clearly better way to do it. Who wins? And the answer is it depends. But it's a fair fight, and you want to participate in that,
Sure.
You got a great chance.
Sure.
So that's where I thought we were. Okay, Xilinx was already a good company, and people were using Xilinx, and Altera was a good company, people were using Altera. But they had this SRAM technique. Actually, Altera didn't even have an FPGA yet. They came out the next year with it. So talking about Xilinx, they had this SRAM technique, which I thought was flawed. Antifuse was better, and we will pillage the market with this thing.
I'm Jesse Jenkins, and I'm simply on the committee that's involved in trying to interview various pioneers and so forth in the area of programmable logic. John's name came up and in one of the meetings, and somebody said, well, does anybody know how to get in touch with him? And I just sat there and said, I don't know if I do or not. Let's try LinkedIn, and it worked. So John was agreeable right off the bat. David gave me some clues with regard to looking up some other interviews that you'd done, and I read through those, and I noticed that in the interviews, a lot of the same ideas and stories were coming up, and I said, it's interesting, and I know this is about John East, but I also wanted to hear John East talking about Actel specifically. And so I thought I might set the stage a little bit in terms of when you finally did accept the offer and come over. We've had a little discussion prior to this, and John shared that he believed there were 54 companies as the number of small companies, each with a different architecture and a different process and so forth, a lot of variety, no consistency in design tools. And I'm going to rattle off some names very quickly. I did them in alphabetical order. At this point in time, the very first one on the list would be Actel. The next one was Algotronics, Altera, AMD, Atmel, AT&T, Concurrent Logic, Crosspoint Solutions, ICT, Intel, Lattice, MMI, Motorola, Plessey, Plus Logic, QuickLogic, Signetics, and Xilinx. And the engineers were confronted with this huge array of capability in these companies looking for business, and so it became a sort of a little mini Wild West. And you went to Actel, initially introduced by Amr Mohsen, but I remember that there was, is it Abbas El-Gamel, and the one that I knew was Khaled El-Ayat. And tell me a little bit about your relationship as you moved into the company with meeting those people, because I think they were the technical founders.
Yes.
So how did that go?
There were actually three technical founders. A man named Esmet Hamdi was the antifuse guy.
Okay.
Abbas El-Gamal was the architecture guy, and Khaled El-Ayat was the circuit design guy.
Okay.
And they were and still are really smart people. Amr Mohsen, a really smart guy. And in fact, there were other people there that were possibly even smarter than those. So when I got there, I was just blown away with the intellect in this company. PhDs from wonderful schools. There were probably 20 people there at the time that were kind of in that category of having been all his life or her life, the smartest person in the room, and the smartest person in the class, the smartest person in the school.
I sense large egos getting ready to bang against each other.
Yeah, it's not necessarily a good thing. It's not necessarily a good thing. And so I think when they offered me the job, maybe the biggest reason they offered me the job was to come in and get these guys to get along a little bit better. They had been the smartest person in the room, and that's a good thing. But one thing about being that smart is I think you often then become less tolerant of stupidity and a little more strict on your judgment of what comprises stupidity. So if there's only one smart guy, you can sort of put up with it. Everybody knows he's smarter than everybody else. But if there are 20 smart guys all doing it to each other,
don't know who to follow.
Yeah, it doesn't work very well. Now they weren't all in that category. There was at least one of those founders that bent over backward to be the other direction. But on average, there were some get-along problems there. That was one of the first things that needed to be solved. But then we moved into problems that were a lot more severe than that, which dealt with the antifuse.
No, I had some experience, not from the process side, but I was at the early part of your career, I was across the street at Signetics. And there was one afternoon when I believe it was Terry Leader, who was the marketing guy, and some of the technical people called us into a meeting to go over to Actel and discuss the possibility of doing a second source relationship. Signetics had been struggling with an antifuse product as well. It got, when it worked great. Yeah, but it had a double of the time programming consistently and having test capability that would let you verify that you were going to ship good product. And I noticed that when we got together with Actel, that the people huddled and all that and walked away, and I don't think anything happened. I just, did you have a lot of those type of meetings with other companies, or?
I don't really remember meeting with SIGs. I'll bet you that happened before I got there.
It could have been.
I got there right at the end of '88. Do you remember when that meeting happened?
I'm not sure.
Yeah, I think I would remember it. Did we have a lot of meetings like that? Well, let me elaborate a little bit on antifuses, and then that'll lead into the types of meetings that I had once I got there. So again, I thought antifuse was better because it would be stable and solid, and you won't risk it being upset and what have you. But of course, the first problem we had, you just alluded to, which was you were in a technical box. If the dielectric was too thin, the things programmed too easily, which meant you'd get things programmed that you didn't want programmed. And if the dielectric was too thick, then you couldn't program them.
Right.
So you maybe think you programmed them, and then they didn't program. Now, the hope was that too thin was thinner than too thick, because if it gets the other way around, you've got a big problem.
Yep.
And depending on the day of the week, we had periods when I wasn't quite sure that was the case.
Now, at this time, who was doing your fab?
Well, so let's lead into that. Then that was the first big issue of antifuses was, okay, let's get a fab, which when I left AMD, Dave, you asked, had I thought it through? Yeah, I thought it through, and I understood it might be a little problem to line up foundries, but I just thought, well, I'm a good guy, I'm personable, I can get people to do things I want, I'll solve this. Really hard problem, because you're going to a foundry, and in fact, there were lots of them out there at the time. That was my judgment. There's so many, we'll be able to get somebody. But they weren't doing particularly well. They were trying to make money, and basically the offer we were making them was put a bunch of engineers on my product and develop my process, and then I will buy 50 wafers a month from you, because that's what we were using at first. Well, even if you lie and say, I'll buy 500 wafers a month from you, it's still a very small number, right? So it's really, really hard to get people to do the work. Our initial foundry was Data General, because they were going to get access to technology, but they closed the fab down. Our next foundry was Merced, because they were going to get rights to sell the product, and they did get rights to sell it. But as I'll get to later, it wasn't the easiest sell in the world compared with Xilinx. So a little bit of that relationship wore off. We got Hewlett-Packard to sell it, because our pitch to them was you can use the antifuse technology on anything you want. But remember, I alluded to the fact later, I'm going to tell you why antifuses weren't that great, so HP later decided I don't want to use it in anything. So it was really, really hard to get good foundries. And we ended up with our dominant foundry being UMC, also chartered a little bit, which is global. And we got to the point where our volume was enough that they noticed it. And then they always charge us extra for wafers, so it was high margin.
Really?
But when they charge us, because if you're the founder, you want to make money somehow. You don't do it because you're just a fine guy. So we always had to pay more for the wafers than we thought we should.
There were still lower volumes than other people were buying them.
Way lower, way lower. The biggest two consumers of foundry in the world, I believe, are still Xilinx and Altera. They buy serious amounts of wafers, so they get what they want out of the foundries. We were way, way, way down the list. So it was tough to get foundry. That was problem number one. Problem number two was, I had a view. It was clear that the process was special and it took a lot of extra work, but I thought we could take the standard process in this fab where they were so happy to see me, they'd do anything we wanted, and they would bolt our extra stuff on their basic process, and our extra stuff was considerable, high voltage and thin films and a lot of evil stuff like that. And that might take a couple of years, but a process node will last maybe 5 years. So 2 out of 5 we'd be 1 node behind, and 3 out of 5 we'd be there with them. And I thought those are good odds because there are advantages that accrue to antifuse and die size,
Right.
and in speed if you're on the same node. So I thought, okay, that'll be a good deal. I like my Harvard case study thing. I'm the new guy, but I like my odds. But what happened was, it probably took us 4 years to get the process bolted on, and the reason is they wouldn't let us start for 2 years. When the fabs were first putting out a new node, they didn't want us in there messing around with it. They had the more important.
They're trying to
variants.
stabilize and all that.
Yeah, they're trying to stabilize it, and they're trying to get the low power version and this version and that version that they thought would be high volume. So we weren't welcome in there for a couple of years, and then it would take us a couple of years to get it done. So we were about 4 years behind, and it wasn't on a 5-year cycle.
Yeah.
It was on a 2-year cycle because that's how often the new nodes were coming around. So instead of being equal to them 60% of the time, we were pretty consistently 2 nodes behind. Well, if you're 2 nodes behind, you're hopeless from the standpoint of density.
Right.
And you're hopeless from the general standpoint of speed, although if there's certain things you're trying to optimize, you generally can figure out a way to do that. So we could only fall back on the reliability that I started out with. That, yeah, it is going to be more reliable. And even in the case of reliability, it ended up not being a deciding factor at sea level, ground applications, crate computers and what have you, because there are upsets, but there are not very many of them.
Right.
They're
Higher
called,
the atmosphere is when you get
that's right.
more upset.
The higher you get, the more radiation there is up there. And in fact, when you get to outer space, I think even today, SRAM configured product will upset every 5 minutes or so, maybe more often. I don't know today's statistics. So there, antifuse was a really good thing. But on the ground in a huge FPGA, people just didn't want to touch it. So you could say, gee, that was good. You found your niche and you moved into it, and we did. But our niche was extremely slow growing. There used to be 100 satellites launched in a year, and today there are 100 satellites launched in a year. So it's not a growth market. The growth of Actel was then, and I hope still is today, in getting a bigger and bigger piece of the pie in the satellite. But it's not a growing market. And in those days, the communications market and the networking market was growing at an extremely rapid clip. And they wanted huge, fast, reprogrammable circuits, which meant Xilinx and Altera. And I wanted so badly to get into that I blew a lot of precious Actel dollars trying to figure out schemes whereby we could get into that market, but never did do very well on it.
John, you just described 5 years of my life.
I'm sure.
Down the street,
I'm
about
sure.
a mile away.
I'm sure.
We went through exactly the same issues with fabs, with processes, at what point you're coming in. And we went through VLSI technology was our first foundry. Cypress was our second foundry. There was a third one after I left. But all exactly the same issues.
Now David is referring to QuickLogic at this point in time, which was also an antifuse company, of which he was also the president and CEO of, right? Correct. So our audience should know that.
So I'm sure it was no easier for you than it was for me. It was miserable.
You were more successful, John. It was easier.
You poor guy.
So one of the things that I spent a large amount of my latter career at Xilinx, and we were observing all the other players as well. I was actually in the smallest business unit, which was the CPLD business unit there. And at lunchtime conversation, we'd be talking about competitors and so forth. And I remember there was a day when somebody said, well, they had Act 1, Act 2, and Act 3. The play's over. And
How mean.
Sorry, I didn't say that. I'm just repeating it.
Okay.
But I wanted to say that wasn't the game over, because you guys went on and did an SX family and subsequent families. And I think you also got into some EEPROM-based products as well. You were going beyond your initial target of what you're at, and you were growing. I remember you guys had, your tool set was growing in terms of the software you offered just as well as anybody else's, if not better than some. And so there was a lot of expenditure of effort and working closely with customers and so forth. You did get into the satellites, but you also got into some military type things, as I recall. And so there was, the thing about both satellites and military is that the volumes are not particularly high, but the margins are. And so if you're dealing with something that's a smaller volume, that's not a bad approach to take. So were there some highlights and some lowlights in that area that you can recall that?
Sure. To begin with, in the Act 1, Act 2, Act 3 days, we still were pretty much after the commercial market.
Okay.
And it wasn't yet clear that the commercial market was going to be completely dominated by telecom and switches and things like that, which it later ended up being. But Act 1, 2, and 3 had some military business, but primarily we were after the commercial business. So the families that did the best for Actel were the ones that came along after that, which were more directly aimed at military.
Okay.
In fact, we started putting RT names on them, RT radiation tolerant. So RTSX and RTSXA, I can't remember what the names of all of them were, but those are more successful than the early Act 1, Act 2, and Act 3
Did you have to
were.
start doing some additional like beam testing and things like that on them to verify that they were gonna?
Did a ton of testing.
Yeah.
In fact, another story that's a little bit of a diversion, but it's an interesting one for me anyway.
Sure.
We had come up with a new family called the RTSX, Radiation Tolerant SX family.
Sure.
It was based on an amorphous silicon antifuse, which is our second generation of antifuse. And it was around 1 micron. It wasn't particularly tight. I can't quite remember what it was. We would do a lot of testing. But one of the many curses of antifuses is to test it is to destroy it. Whereas with an SRAM, you just program this in, test it, and then program that in, test it in the same unit. You can test a jillion things. But with antifuse, to test it is to destroy it. And these were big die, not that many good ones on a wafer, to get as many units as you would want to test in as many different directions as you would want at all the different extremes of temperature and et cetera, was a big job. But we thought we did it well. And so we got this family out, and we had people actually waiting to use it. And the first guy that was waiting to use it, the first application waiting to use it, were the Mars rovers. Because they understood well the benefits of antifuses, because they had the problem of wanting ASICs, but how many ASICs do you want, sir? Oh, I want one.
Right.
Well, you can't get an ASIC company to do that for you, so you really want to do it with an FPGA. Actually, in their case, they wanted 4 plus some spares.
Sure.
But they recognized the benefit of FPGAs, and so they designed their system on the come, assuming that the Actel RT product was going to work well.
Right.
We had the commercial product out already, so they could prototype it, they could build their computer, they could prove it worked and all
But
that.
they couldn't do the final testing on the sort of thing.
That's right, and they couldn't send it up into space to Mars until they had the RT version. So we got it out, and we thought we tested it till it turned green, and everything looked really good. And sold them some units, and they put the units in the Mars rovers, and in the summer of 2003 launched the first one, and a couple months after they launched the second one. It was about 4 months to get to Mars.
Okay.
In that interim, a scare came up with respect to the reliability of the antifuse product. And it wasn't that they all go bad. I've been involved, Dave and I were talking about, we've had real reliability problems where, see that circuit? It's going to go bad, and I'll tell you when it's going to go bad. Well, this wasn't that. And by the way, that's a not fun problem to have.
No.
But this problem was, 1% of these circuits might go bad if they're in a certain environment. And they might not go bad. And we're not quite sure what the environment is that caused them to go bad. And these were customers that were coming back, not the Mars rover people, but other customers saying we're having some funny things happen. So we got together with Aerospace Corporation, which is a government-sponsored thing down in Los Angeles. And that's the closest approximation I've ever seen to Actel in the early days. Staggering numbers of really smart people down there with really expensive equipment. They had equipment that we didn't have, and we all got together and started working on it. And even all together, we were having a hard time sorting out, is this really going to go bad or isn't it? And what's making it go bad? And we were having a really, really bad time figuring that out, and having arguments with each other. And meanwhile, the Mars rover lands. Rover comes down with it was wrapped in kind of balloons with a parachute and what have you, and opens up the solar cells and starts to run around, and everything is looking good. It's great. Everything's great. A week later, headline in the newspaper, Mars rover goes bad, quits talking. Uh-oh, I wonder what that is. And the answer was, we don't know, but we'll find out, because the diagnostics on this thing are second to none. We're going to know exactly what the problem is. And it smelled like the kind of thing that people had been telling us about. And by the way, we didn't have one unit in there. It was made out of us. I think there were 76 Actel FPGAs in there. So it's not like, well, this one unit will go bad and one little thing might not work. It's, oh, geez, you know, if one unit goes bad, the whole damn thing doesn't work. So I remember looking at the symptoms, and we had a little bit of access to that through our contacts there, and thinking, it could be us. And I remember going home that night, telling my wife about it, opening up a bottle of wine, and I drank the bottle of wine that night. And I like a nice glass of wine, but I don't drink a bottle of wine. But that night I was, oh my God, I'm going to be all over the front page of the paper.
A little anxiety there.
I'll be famous. Actel will be famous. You know, this is going to be terrible.
Chinese taken away in chains.
Yep. Turned out to be a software problem.
Excellent.
And none of the Actel circuits ever went bad. And by the way, the rovers are still up there working, and it is 13 years later, and they still work.
I got a T-shirt you need. It says, "Don't blame me, it's the software."
I needed it then. So they fixed that. And that actually put us on to a potential problem, that once we were onto the potential problem, once you know there could be a problem, you can fix it, right?
Sure.
So I would say today that those things are the most reliable FPGAs you could ever find, most reliable circuit of any kind you could ever find.
It's interesting, though, that there's been a lot of this effect of having the vehicles go up there with an expectation of a lifespan of so many months or whatever, and then finding them actually outlive their expected lifetime to where they're now changing the ground team that's supporting them. You know, they're retiring while the things are still running, which is very cool.
It's cool, and it's a lesson in life, because so much of the world is about ragging on the guy that works. And, oh, he should have this, he should have done that. They're bad guys, and they try to ship junk, and of course, they're evil people. And the fact of the matter is, there are some evil people out there. I've met one or two of them, but on average, just hardworking people trying hard to do a good job. And when you know you're going to be in a Mars rover, you bend over backward trying to make sure that you make a good part. And what you're describing is a result of that. A bunch of people who work really hard trying to make sure they did a good job. And you know what? They did. They did a good job. And I'm not just bragging about Actel there. The Mars rover, shockingly complex thing. How could you ever get that done and make it work? It's amazing. Those guys should get accolades.
Okay.
In fact, you told me it's okay to digress.
Please.
As a CEO, you would get invited to do a lot of public speaking. So I did my share of public speaking, and I was once invited to speak at NASA because we were in cahoots with NASA. They actually had a division responsible for FPGAs there. Some really smart people were in on it, and we'd work with them all the time. And, they had a annual conference called Maple D.
Okay.
I don't remember what that stood for, but the PLD would be programmable logic device. So what's the M?
Probably military aerospace.
Yeah, there you go. Maple D, there you go. Military aerospace programmable logic device. And they asked me to go speak at that, and there were just a whole bunch of guys that I just loved to death, because they're your basic physics, smart, nerdy, work hard, pride in your work kind of bunch of guys.
Classic nerds.
Yeah, and you love them to death, and they're in there, and they're just coming out from being beaten up really badly, because this would have been after the rovers, I guess, but they had a lot of trouble with Mars. Most of the stuff that people did with respect to Mars didn't go well. Maybe this was before the rover. I can't remember the timing, but anyway, they'd been beaten up. And do you remember the incident where something didn't work because the one diagram had something in a metric scale and
conversion from metric to
yeah. Yeah.
linear. Yep.
And so this huge, complicated thing failed because of that. And of course, the result is they're all stupid and lazy. And how can Americans tolerate that? And these are the hardest working, smartest, most lovable guys and gals that you ever want to see in all your life. And they had several other things like that where they were just being flogged. So I stood up and gave them a talk that was sort of based on which president was the one that said the glory ought to go to the guys, the people actually conducting the fight, and not the narrators telling them what they did wrong, what have you. It was some president that did that one, Roosevelt, and stuff like that. So I gave them, my version of that, which was doing stuff is hard and critiquing is easy. And I'm amazed at the things you guys do, and I'm proud to say I know you, and don't let this get to you. And I got a standing ovation at the end of that. Standing ovation. And all I did was give a lousy talk. They were the ones. They were the ones that did all the work. So I guess maybe I got a little bit far from your point. But
That's fine.
doing honest work in this field is not easy, man. This is complicated stuff, and there's so many opportunities for things to go wrong. And if you make anything like that work, you the man or you the woman, because it's full of women. Full of women, the field is.
I hadn't discussed this with you prior to this, but I thought I would bring it up. The one interaction that I actually had two interactions with you. One where I interviewed at Actel, and actually at the end of my interview, I was invited into your office, and I was very surprised when you very openly pulled up your computer screen and started showing me the spreadsheets of how you're doing. And I'm sitting there going, I've never had somebody who runs a company sit here and show me how the bottom line's going. It just seems like open kimono to me. But prior to that, I had actually, through my personal relationship with Khaled Elliott, I was consulting for about 18 months between Signetics and Xilinx, where I worked next. And Actel was in a legal tangle with Xilinx at the time, and they needed somebody who was not working for either company to come in and take a look at some of the patents and so forth. And I did that, and I probably was one of several. I hope it was, because you guys did manage to resolve the thing. But there was a statement that you made to me, and there probably were other people in the room, but you made the comment that we have to get this right, because if we can't resolve this technical issue with the courts, they want to put a padlock on the front of the building, and people's jobs are totally at stake here. They'll be turned away. And I just sat there. It struck me with the amount of responsibility was on your shoulders and how you felt it, and that you needed to make sure that your people that looked up to you were having the right thing done. And I just wanted to give that little statement, because it was over 20 years ago, and I remember it quite well, because I'd never met a CEO before who was that open with me and who was expressing his concern so strongly for his workforce.
Wow, thank you.
I was totally blown away.
Thank you. You reminded me of 2 or 3 different directions I could go.
One of them was a nightmare, though, right?
So let me go both directions. The most important direction I'm going to put off for a minute. Yes, you were helping us with our patent battle with Xilinx. Of course, they sued us, and I asked to be licensed, but they didn't want a license, and I don't blame them for wanting a license. That was Barney von der Schmidt, a very nice guy, but why would he want to license me? I was just a competitor. So he made it clear that no, we were going to take this to court, and we want to shut you down. I think what actually would have happened is they would have bought us for pennies on the dollar, given that we were in a position of take whatever they offered us or put a padlock on the door.
Can I interject something?
Yeah, absolutely.
Did you know that at the time, Xilinx was also doing an anti-fuse product?
Yes.
Okay.
Yes.
Sorry.
Yes, it did. And so that was our whole approach. We could argue we didn't infringe the patent, but it's just a coin flip, because these things are so arcane, and the jury is going to have plumbers and housewives and English majors.
Absolutely.
And I don't understand this, and whoever had the best lawyer wins. So we
or
couldn't
if it's
depend
in
on
East
that.
Texas, whoever has the patent wins.
That's right. That's right. So our deal was we have to find some patents that we can assert against them, and that's not the easiest thing in the world, but we actually ended up doing that. And then when we had patents to assert against them, then we were able to settle. So we were happy. We lucked out there. Immediately afterward, we got into the same battle, myself against Dave Laws. Ended up the same way. And in both cases, I'm going to say $10 million spent. But there's no way out of it.
And it all went to attorneys.
Yeah. There's just no way out of it. I know I had no way out of suing your deal, Dave, because you remember the Berkner worked at Actel.
I do remember the story.
A lot of bad blood, most of which came from Caladella Yacht. Not most of which, but a lot of which came from.
I was going to say, John mentioned his consulting for you guys prior to forming QuickLogic.
Yeah, he was. The story there, and John's a good guy, and I know he mentioned to you that he and I lived next door to each other in the dorm at Berkeley. And he's a good guy and a smart guy and all that kind of stuff. But he made one tactical mistake, and that is when they founded QuickLogic, they were trying to get some press, and they had a nice article in E! Times, an excellent article, talking about how they would get together in H.T. Schwa's garage every night after work, and this was in 1987. Well, Berkner was working for us in 1987, and he was working for us in 1988, and the product they came out with looked an awful lot like our product, and it made the people at Actel, remember these people with the IQs of 200 who all wanted all the credit themselves?
Steam coming out of their ears.
Oh, gee, it was terrible amount of steam, so they would have run me out of town had I not filed that suit. But in any event, I got mad at Bernie because he filed against me, and then I turned around and filed one against Dave, and I love Dave Laws. So I don't know what that goes to prove, but life is perverse. But flipping back to the more important thing, everybody has the view of CEO. I mean, he makes the big bucks and has it easy, and he goes and plays golf and does these sinister political kinds of things, and then cheats on his taxes, right? I mean, that's the average view. Hey. That's not the average CEO, okay? If you look around long enough, I didn't much like the Enron guys, and there were a few other bad guys, but on average, CEO is a tough job. Yeah. I didn't just describe Dave Laws as a CEO when I described that. When I describe Dave Laws is miserable 90% of the time, because there's just, most companies are not the next Apple computer or the next Intel or whatever. Most companies are just, man, it's a grind, and if you don't make payroll, I mean, if you don't do this, that, or the other, you don't make payroll, it's a tough job. So you put the question on the table of, you're going to put a padlock on the door. Yeah, that was a huge concern to me, but stuff like that would come along every day. And in fact, the biggest issue I had, you sent me a little warm-up, or this was on your warm-up, but what were the biggest problems you had? And the biggest problem I had was handling that on a day-to-day basis. The people work for you. My particular management style was no secrets, put cards on the table, which is what you described there, because if you don't play it that way, eventually people know you're trying to pull the wool over their eyes, and you lose their faith. So you have to be honest with them. But the honesty, one of the honest things was, I don't like the antifuse anymore. I don't at all, and that's all we've got. Yeah. So here I am every day worrying about where are we going to go with this thing. I haven't figured it out yet, but still have 500 employees, and you got to tell them it's going to be all right. And that's hard to. It's
and
hard.
You did this for how many years, John?
22. Well, 20. The first two, I still believe that antifuse is okay. And so so that you can be totally honest, you've got to say, as is, we're having trouble, but we can do this, we can do that, we can do that. So you just got to work harder and get that done, and that's our way out of it. But it's not an easy thing. So
it's the longest stretch you ever had without a promotion.
Yes. Yeah, and I was aggravating me. 22 years I didn't get a promotion, and prior to that I'd get them every couple of years. So Dave, whatever they were paying you, and it wasn't the big bucks that CEOs make, I know, it wasn't. You earned every penny of it, and you got an ulcer and a few white hairs from doing it.
They were interesting times, John.
It is not easy work. It is not easy work.
Have you got anything else, David?
Well, I'd let John eventually became sort of an elder statesman of the industry, John, right? And you were involved in things like the Fairchild Semiconductor Association. Mm-hmm. Weren't you on the board of Regents at Berkeley?
An advisory board.
Advisory board. Tell us about some of the things you did on the bigger scale that came out of your experience.
Okay. I did end up being the senior guy, but that was really unfortunate. When I got there were many companies, and many more came along. But the only ones to thrive were Xilinx and Altera, and then I always put Actel in their league, although we probably didn't quite believe in that. In the early days, Lattice didn't have an FPGA. They came along much later with the FPGA, so we always kind of pushed them into, no, that's just a CPLD. So in the early days, there would be lots of conferences where the 3 FPGA guys would be invited to speak. So I got to know Bernie and Rodney pretty well. And I'd met Bernie before, and I liked him. He was a real gentleman. So we would go and give talks, and in the early days of those talks, I would tell everybody that we're going to cream these guys because we have the antifuse. Then the rumor got out that Xilinx is actually working on antifuse. And I got to know Rodney a little bit too, and I thought he probably would start working on them. But anyway, I got to know those guys. And they were totally different guys. Bernie, the nicest human being on the face of the earth. And he always used to draw the diagram of the management structure at Xilinx as an inverted triangle, inverted triangle. And he was at the bottom, taking orders from his VPs, who took orders from his directors, and he believed that. And he
customers at the top.
The customers at the top. And so he was a gentleman. He would listen to you. I don't think he was a technical giant, but he was technical. He had been involved in the development of color TV.
Yep.
And just a very gracious human being. And he let his technology and his people go conduct the fight for him. Now my Rodney story, bless his heart, was not the same story. Okay, I had not met Rodney Smith, but I'd heard about him, and we all got invited to speak at the Dick Schaefer conference in Boston, and this was right after I joined the company. I think it was early 1989, and I didn't know Rodney, but there was a pre-conference wine hour where everybody got to go drink wine, get to know each other. And so Bernie was there, and I talked to him a little bit, and he was gracious, although you could see he wished he didn't have any competition. And also, in retrospect, he was already planning to sue me. He hadn't yet. But he was a gracious guy. Then I asked, well, who's Rodney Smith? He said, guy over across the room. So I went over, and he was talking to somebody. I don't remember who the heck it was. And I kind of tapped him on the shoulder. I said, Rodney, I want to introduce myself. I'm John E. He stuck my hand out. He just turned his back around a little bit. And I'm there with my hand stuck out and thinking, well, this is not... and he was letting me know that you might be a nice guy. And if you lived next door to me, we'd probably have a beer together. Yeah. But you're my competitor, and I'm going to kick your ass.
I couldn't imagine 2 more different management styles building such totally successful companies.
Yeah.
Different styles. Bernie was bottoms up. Rodney was tops down.
Yep.
And there was just no other way to differentiate.
There wasn't. Now, I need to clear up that I wasn't trying to put the kibosh on Rodney. I later got to know him a little bit. In fact, we would go to the Needham conference and the Goldman conference, and always be a group of IC guys would go out and have some beers afterward. Sure. And Rodney was one of them, and Jack Gifford was one of them. Jack Gifford, a lot like Rodney, right? A lot like Rodney. But there were not 2 guys in the world more fun to go have a beer with. They knew how to drink their beer to begin with. And good senses of humor and just clever, and but they differentiated between friendship and war. And yeah, you'd be friends, but war is war, and you fight war to beat the other guy, and you kill him in any way you could. And so that's the way he was. Sure. But how did they become the senior statesman? They both died. Really good guys who the world misses. The world does miss them. Unique people. And that left me. So I didn't get there by being better, just by living longer, Dave. Then
that's just another tactic.
I did stay engaged with Berkeley for a long time. They had an advisory board for the EECS that I was on for quite a while, but I think they disbanded that board. Now I see a few of those guys. I see Alberto Sangiovanni Vincentelli now and then, and I'm very proud to say that I'm from there. But they're so far ahead of me. Why would they want to stay in touch with me?
But did they listen to you on an advisory board? Were you able to contribute anything that you saw any result from?
Well, it's interesting. What would you talk about on an advisory board? You'd think, wow, you talk about the upcoming technology. Yeah, a little bit, except I'd always come home with my tail between my legs, because it turned out that whatever upcoming technology I might be aware of, they knew more than I did about it, and they were already ahead of me. So their biggest problem, and I wouldn't be surprised if it was still their biggest problem today, and gee, I'm trying to figure out if I'm going to violate some EEOC or look prejudice or what have you.
Some NDA you've signed.
Yeah, no, not an NDA kind of a problem, but their problem was this: we want to be the best engineering school that there is, and they were typically in the top 3, top 4, top 5, top something like that. So how do you do that? Well, you have the best professors, and we do. Of course, everybody says that, but they may well have. Second thing is you have the best students. Now, we look really hard to try to find the best students, and for some reason, we don't understand it, but for some reason, when you get done trying to find the best students, they all have Asian surnames. Now, they're not necessarily all Chinese or Vietnamese or whatever.
Sure.
Some are from here, second generation, third generation, but they all have Asian surnames. And lots and lots and lots of them aren't Americans at all. Lots and lots of them come from Taiwan, China, Vietnam, Korea. Those are the very best students. Now, we're a state-sponsored school. We need to somehow cater to the people from the state. But I wish they were the best students, but they're not the best students. So what do we do? And every time we had a meeting, which is only once a year, we'd start out with that one. And fundamentally, you end up punting, right? I don't know the answer to that, except that, boy, if you were to ask me about my political beliefs, well, okay, I'll even get into that a little bit. Not without saying who I'm going to vote for or what have you, but
Well, come on.
young people coming to Actel would invariably say, how can I succeed? How do I get to be the CEO? And in fact, we had maybe a decade period where we'd hire 25 or so interns every year, perversely enough from the University of Toronto, because they had a really good intern program. And they would always ask, John, how can I get, how did you do what you did? How can I get where I want to get? How can I get ahead? And I had these kind of canned lectures I'd give them. I knew they would ask me, and so I knew what I was going to say. So I changed the name of this a few times, but fundamentally the issue is this. Okay, you want to get to the top, here's what you do. You go to college and you study something practical. And you may not necessarily like it. There are probably things that aren't practical that are more fun. You study something practical. You get a degree in that, you go get a job, and you do a practical job, and you do it well. And you know what? There are going to be times that you don't like what you're doing. Do it well anyway. There are going to be times you wish you'd done something else. Do it well anyway. Do it so that your boss says you're the best guy there. And the only time you ever say, I quit, is when you have a better job lined up. If you do that, you're going to succeed. And do you know what they would say to me invariably? You sound like my mother. Okay. And so I abridged that to the Chinese mother principle. So when they would ask me, I'd say, I'm now going to tell you the Chinese mother principle.
So maybe your name is really John Far East.
Could be, could be. So how does that relate? Well, it says to me that we having a problem as a nation. We can't let them do that to us. I am all for people getting free everything. Free is a good deal. Free medical care is good, and free education is really wonderful. I really believe in that, really believe in that. But if the whole platform is you get it free, I don't like that. I like the whole platform to be, let me teach you the Chinese mother principle. And I'm going to tell you that once a week for my term in the presidency until it's there, until everybody understands the Chinese mother principle. That's what you're going to do.
What would you like to run?
They'll get rid of it. Once everybody understands that, now I'm all for education should be free. Healthcare is really expensive. You need to take care of that. But if it's just vote for me and I'll give you that stuff for free, it's the wrong direction. So who am I voting for? Well, I'm moving to Canada. That's.
Well, they're going to build a wall, John.
Build a wall to keep me in.
Keep you in.
Okay.
Keep you in.
Okay. I think I fell far. I went far away from whatever your question might have been, Jesse, but I don't remember what it was.
I don't either.
Oh, I do remember what it was. It was what were the big problems? Oh, well, we went from big problems to what were the interesting things that you did? And the advisory committee was there. Sure. I'm now on some boards of directors and some other advisory committees, and that's fun to do.
Sure.
There's a lot less worry than the CEO job you and I did. CEO job is not good for sleep or hairlines or ulcers, bad
Just
guys.
give some thought to it and give some advice. as
Yep.
yeah.
And when your advice is wrong, as mine often is, you get to just say, as best I could do, I thought it was right. Whereas if you're the CEO of a company, there are repercussions.
So, as you have ended your basic technical and managerial type career, and you're in what we would call a retirement mode, you have shared that you have some grandsons, and you've shared that you have an interest in going back and relearning or learning for the first time some physics you didn't have the opportunity to do. Are there any other plans on your agenda? You mentioned that you like to travel.
Yeah, well, yeah, it's there's not much good to be said about being an old fart, Jesse.
I know, I
but you'll know
understand
soon
that
enough.
very well.
But one of them is you do have time on your hands. So yeah, my wife and I take 1 or 2 cruises a year, and that's just fun. There's no problem with that. We babysit maybe 4 or 5 days a week for my grandsons, 1.5 years old and 5 years old. And then the really idiosyncratic thing you mentioned is, I always was in awe of Einstein, and wondered, how did he figure this stuff out, and what is it that he figured out, and how can space be warped? And oh my God, this stuff is fascinating. But it struck me when I retired that he came up with those things 100 years ago, more than 100 years ago now, and people have moved way, way, way past that. And it should be understandable now. So I've decided, when I die, people are going to say he understood Einstein.
Excellent.
And I'm well into that, but I'm not at the end yet. I'm not at the
That
end.
carved on your tombstone, Joe.
Yep. Yeah, I could
He
in fact.
understood.
I'll put a virtual tombstone or something.
General relativity, the equations of general relativity on my tombstone. That'd make me proud. Actually, the equations are pretty simple. They're pretty short. It's just, what does that mean? It's a little hard.
So you've been following the Jupiter mission with great interest, I imagine.
You know,
Because that's important in part of the general relativity analysis.
It is, but I haven't been following it until they start flashing the results of it.
Yeah.
The one that I started to get into, but I've realized I don't know enough background yet to really understand it, is the Higgs particle. And that's not really Einsteinian, but I'm going to get to that. But the Higgs particle, of course, they predicted, and then they found it, and somehow it's what determines mass.
Which is key for gravity, which is key for everything else.
But I bought a couple of books on the Higgs particle when it came out, and they're all written for laymen, which means you can understand the book. But there's a huge gap between what the book tells you and what this thing really is, right? I said, well, what's in this gap? So I have to learn that, and before I learn that, I got to get done with the general relativity. And
Yeah, it's easy to get involved in too many things. You need to focus.
Yep. So anyway, general relativity, then the Higgs particle. By then there'll be some Jupiter mission stuff, but I'm not into that yet.
Right. Anything else you'd like to leave us with, John, as a message? I usually like to ask people what you would tell young people who are planning to go into a science career today, but I think you've already answered that very eloquently. Is there anything else?
Get yourself a Chinese mother, and
Right.
you'll be fine.
Excellent.
Okay, that's be my advice.
Sure.
And
Excellent.
I'm not sure who or where or when this is watched, but to anybody who might watch it, you ought to come into the Computer Museum. This place will blow you away.
Yeah.
You guys have done a really, really good job, and I'm proud to say I know you.